Not earphones. Unamutwa earphones.
Hello, guys online. Hello, good evening.
Good evening.
Yeah, guys, you'll pardon me. I'm late. There's been a heavy deployment, I think, around Ugolobi, so the jam is really tough. Not necessarily deployment, but I think there are some road works. So I really disturbed my travel, my coming. But that's again personal. So I regret for being late. Jam cannot be a reason. Okay, let's see how much we can cover. But tonight, I'd like us to look at the Lorenz curve, the Z chart, control chart. If really time allows us, I think it will. We did that big part of the introduction to charts yesterday, so we're going to move really quickly. Yeah, let's see how much we can do. But those are key on my schedule with you, so I hope we can achieve. There was something in August 20. Oh, let me see what we did. Yeah, guys, graphing, I need to re-emphasize. Graphing is done with a pencil. I've seen people who told me that whenever they have been doing the paper, they were doing graphs with pens and in black pens. Good evening. Yeah, I was told, but where I have been, I didn't have a chance to touch personal stuff. That was my challenge. Yeah, frankly, I'm going to do it probably during break, but I would like to send everything plus tonight's class. So I'll try to share again. But then also the file I think is heavy, so I need to find a way of you getting it. Okay, I can do tonight's work on actually separate sheet so that we don't miss it. Let me open another sheet. Yeah. Yesterday was class 13. Today it's class 14. So Friday, August 22nd, 2025. Rev 13. 14, eh? Okay. Okay. Lorenz curve and the Z chart. What do I see first? Which one fits in what we were doing? So I think the Lorenz chart will fit in really well, so that when we do the Z chart, we go into a time series as well. Okay, so the Lorenz curve, the Lorenz curve or charts. We are saying that this is a cumulative frequency, a cumulative percentage. Pardon me. This is a percentage. This is a percentage cumulative frequency curve that is used to assess the income distribution within a population. Okay. It is drawn with the cumulative, with the percentage cumulative frequency of the variable against the percentage cumulative frequency bracket number against the percentage cumulative frequency. So it's a unique graph. It is that graph where you'll have cumulative frequencies on the horizontal. So this is what it looks like. I don't know if you heard of the Gini ratio. The Gini ratio looks at percentage or degree of distribution of the income. So it looks like this. So you'll have what we call the line of equal distribution. And then the Lorentz curve comes like that. Okay. So this is the percentage cumulative frequency of the value that is x of the variable, value of the variable. And then this is the percentage cumulative frequency, okay? So this is what we call line of equal distribution. And this is the Lorentz curve. The Lorentz curve. Okay, so this degree here is at a 45. Usually it's a normal distribution of incomes. Now, the closer, if there was an interpretation, the closer the curve to the line of equal distribution, the more evenly the incomes are distributed within the population. Okay? So that gap there, if we had, let's say, if you can follow the red, if I had something like that, where the red line represents the Lorentz curve, let's say, the black one, there's a bigger disparity. With the red one, the incomes are almost evenly distributed. So the farther the Lorentz curve is away from the line of equal distribution, the bigger the disparities of the incomes. Now, this same one can be used for production, costs of production. You'd like to see if costs of production are equally or evenly distributed within the units you're producing. I'll give you an example. You may, when you produce 2 units, your costs of production may be higher, okay, than when you're producing 100, the cost per unit. So that means the more the units, the more economies of scale you'll enjoy. I'll give you an example, like where you are here. This room can have capacity of 45 students. The lighting and maybe the chairs used by 45 students can be used by 10 or are being used by 10 students, for instance. So that means as a college, you enjoy economies of scale when you have more students as compared to when the students are fewer. So you incur a higher cost of service on service delivery when the students are fewer than when they were many. I hope you get me. Okay, so this is the same thing, that where you have a bigger disparity, then probably you are incurring higher costs on fewer units than if they were many. Okay, so there should be even distribution of the costs. We are not saying that the unit should be almost the same cost, but it should tend to a similar price or cost. Okay, yeah. Yeah. You mean what we did yesterday? Okay. Yeah. Oh, importance of frequency polygon. Yeah, it allows for ease of data analysis. A frequency polygon is a chart. It will tell you how data or how the variable is distributed in terms of how many units. Like for instance, if you are looking at units sold vis-a-vis income, vis-a-vis revenue, and you generate a frequency of polygon. So you are able to tell, when I produce so much, this is my level of production. It's like a bar graph. A frequency of polygon is a bar graph. That's why we generate a histogram from a frequency of polygon. So when that question is asked, you tag it to charts. What would be the benefit of having a pie chart, for instance? What would be the benefit of having a histogram or a bar chart? They carry the same. So usually they give visual expression that even without you writing too much, someone can easily do the analysis. It is said PowerPoint should not have notes. When you're preparing a PowerPoint presentation, you shouldn't write paragraphs. But okay, I mean, we present different. But in most cases, people do paragraphs and they read. A PowerPoint usually a visual. They are visuals, or if you are writing, there would be like bullets. Yeah, and then you'll find that most people use diagrams in PowerPoint because they feel that way they're expressing the point. And that's why it's called, maybe that's why they call it a PowerPoint, that someone does not need so much of the explaining. He would like to look at it and then ask you questions. Yeah, like when you have this visual, we just need to explain what the details are. But then in a PowerPoint, you have where you can put notes. I don't know if you've seen that. I have a presentation, but as I present, I have some notes that I'm reading that you cannot see. PowerPoint allows that because they know you have a diagram, and down here you'll have some notes you can explain to people. It's not necessarily a Word document. So then the guy who taught me PowerPoint said there is power in three. You write three things on a PowerPoint. The most you can write would be 5. Don't go beyond 5 bullets. The reason is simple. When you write 5, people can at least remember 3 things. When you write 8, they'll remember 3 or 2. So when it is crowded, there is a way. But anyway, all in all, graphs summarize data for ease of manipulation and interpretation. That's how I can put it. Yeah. This bit of easy to interpret and the like, but it's mainly for data analysis. You go out in the field for you collect information, and then you should present it to us in a simplified way, which includes graphs, it includes summaries or photos. Yeah, that's how I can put it. Okay, that was a nice one. Okay, so we take an example here. So one of the questions actually that you may be asked is the importance of a Lorenz curve. It is used to analyze the income distribution within populations. But it does not necessarily hit onto that. When you look at production, you'd like to know how costs are spread within the units being produced. Then also, when you are giving out maybe a grant, did the beneficiaries get it? So you can still use a Lorenz curve. But mainly in economics, it is meant for income analysis of income distribution. Yeah. Okay, let's take an example. I think I have a question I put aside. Guys online, I hope we are together.
Yeah, we are. Good evening, sir.
Okay. Good evening. How are you? You sound like Friday has started. Example.
Wechiri.
Okay, nice. Nice. Example. I have 2 examples here, but I need to see which one would summarize it really well. My 2019. Come again? My 2024. Just a second. Just a second. Let me first see this one. Was that again? I think I messed up this. My 2019, I said different question. Oh, yeah, it is construct Lorentz curve. You said my 2024. I just need to check it out. Which question? Oh, now this one is summarized. Okay, this one is summarized. They have done a couple of things for you. I would like us to go to the other one where we generate stuff for ourselves. Okay, so we go to, I've seen it. We go to my 2019 where you generate the things yourself. Okay, my 2019, guys, is right here. May, not my. Okay, May. Right here. This is what we were talking about yesterday. You see such a question here. Sometimes they may ask such a question after you've drawn the cumulative frequency curve. So what people do, at times you'll find them trying to use the formula. The formula is lengthy. You just go to the graph and you pick the figures. And if you could, without them telling you to use whichever method, you can use a graph because you read all the figures straight. But anyway, people should use what they feel comfortable. Okay, may someone online read for us, part B? Someone online, please read.
Okay.
To
Can I
cross
read?
Burkina Faso border.
Keep going.
You can go ahead
please.
and read.
Okay. To cross Burkina Faso border post, a tourist is required to present his or her bank statements showing his or her account balance in US dollars. The following table shows the distribution of the account balances for a sample of 92 tourists in December 2018. So they give us the account balances 0 to 100, 100, 200, and the last being 700 to 800, including the number of tourists. The customs manager at the border would like to get this data further analyzed for management use required. Calculate Bowley's coefficient of skewness for the data above. And then number 2, construct a Lorentz curve representing the account balances of the tourists.
Okay, you really read well. You must be a manager somewhere.
Yeah.
Okay, that's a good one. Yeah, so guys, watch out for such. Formulas are at the back, but sometimes if you don't practice with them, it presents a challenge. Here, there were like 16 marks in one question. Yeah, over 16. Remember what I sent you? The question I sent you, you remember? Systematic, those short quiz questions. So the difference, distinguish between systematic sampling and multi-stage sampling. So multi-stage has cluster and quarter sampling. Okay, kindly look at them. Those little questions I kept sending you, you remember? Yeah, their definition, then population mean and sample mean. Population mean is mean of a what? So you should know what a population is, what a sample mean is. So some students do this. They'll tell you population mean is mu equal to summation x over n, and sample mean is x bar equal to summation x over n. Okay. Now, when they are defining, actually here they'll use small n. When they are defining, he'll tell you where mu is the population mean, where x is the population detail or population variable, and n is population size. Then they come to this and they say where x bar is sample mean. This subject allows you to do this. You can define like this, okay? Where x are the sample values and n is the sample size. No, you don't need to. You don't need to. Ungrouped data gives the basis. Ungrouped data is the raw data you have to group. So either way, the start is having ungrouped data. So you don't need to go ahead. This is for ungrouped, this is for grouped. No. Yeah. You see, even for grouped data, when you do this over n, this is a total. So the question is, what is summation x? Summation x remains summation x for ungrouped, but summation x is summation fx for grouped data. Okay, it's all about summing up. Yeah, so you can use just this. Besides, there were 2 marks. Okay, what did I do? That's not what I want. Okay, so guys, together, the first thing we are going to do, did I mention? Maybe what I didn't mention. So fast forward. I don't know if you wrote the example, but let's cancel it here. What do you need? Okay. So the process or what do we need to follow? So we need, before we solve it, I need to show you this. We need 1, establish the establish the frequency. Sorry, establish the percentage cumulative frequency for the frequencies given. Okay, and then establish the percentage cumulative frequency for the class marks. You will need to have to determine the class mark. Then from the class mark, determine the cumulative. Why did I say cumulative frequency? Percentage cumulative value. I'm sorry. Percentage cumulative value. Percentage cumulative value. X. I hope I didn't do it up here. Against the percentage cumulative value. I'm sorry, guys. Percentage cumulative value of the variable. Okay. Now, sometimes you may not be given classes. They may give you just the value. So it's the one you use and get the percentage cumulative. Okay? So let's take our example. So our example is the my 2019 question 1. Okay. So we pick on question 1, part B2, part B2. So we're going to generate our table. We are not redrawing this. Okay, so our table is going to have the balance. Okay, account balance in USD. It will have number of tourists is F. Okay. Now we need X. Are we together? Then we shall need percentage F. Then percentage, okay, percentage F, then percentage cumulative frequency of F, then percentage X, and then percentage cumulative of X. Okay, so these balances are 0 to 100, 100 to 200, 200 to 300, 300 to 400, 400 to 500, 600, and then 700 to 800. Okay, our F is 4. We have 8, 13, 18, 22, 15, 10, and 2. May someone help us with X? Remember
50.
for X? Come again?
50.
50.
150.
150.
250.
250.
350.
350.
450.
450.
550.
550.
650.
650.
750.
750. Okay. What is the total frequency?
92.
92. So percentage F will be each of these divided by 92. So we have 4 out of 92 times 100. You give us to 2 decimal places. Actually, sometimes we round off to 1 decimal place. 4 point?
4.4.
Excuse me. Can you give us to 1 decimal place?
4.
4.4.
4.4. Now, just a second. 1 decimal place.
Not 4.3.
We take 2, eh? We take 2. The 1 decimal place may give you something more. Okay? It may raise it higher. Okay, 4.35. Let's keep 2. Okay. Next.
8.6.
6 what?
695.
8.7.
695.
695, which is 70. Good. And then next.
14.13.
Nice. 5.7. The next one is 23.91. 16.30. Okay. 10.87.
2.17.
2.17. Perfect. Now let's get the cumulative values. The first one will be percentage cumulative frequency. The first one is what? 4.35. 13 point. 13.1. 0.5. This is 27.18. This is what? 40. 46.75. And then this would be 70.66. Okay. This is 80.
86.
9 what? 96.
96.
And then this will be 0.3.
0.83.
And then this will be
Of course, 100.
100. If we had maintained one decimal, we would have like 101 or 100, something extra, usually when you round off. Or it could also come up to 100 straight. Yeah, so just for the sake. Now, Francis, what do I do? When you are doing it, show the examiner that you are maintaining 2 decimal places for accuracy. When it comes to plotting, you round off the nearest whole number. Like for instance, 27.18, I can plot 27. Or I can plot 27.2. It's not so far away. But in computation, I show him. Okay, what is total X?
Francis, how did you get the cumulative frequency?
3,200. Oh, sorry, please, come again.
3,200.
How did you get the percentage cumulative frequency?
Oh, okay. Usually the first cumulative value is the same as the first frequency. Okay. Now for us to get 13.05, it was 4.35 plus the next frequency, we get that.
Okay, thank you.
4.35 plus 8.7.
Yeah, thank
now,
you.
Now to get, you've understood?
Yeah.
Okay. Guys, we move in. We move in. Yes. Total X is 3,200, right? So to get percentage X, it will be each of them out of 3,2 times 100. We are maintaining 2 decimal places. What do you get?
1.5.
1.56.
1.56. Okay. Next.
4.69.
Keep going. 7.81. 10.94. 18.0. 14. 14.06. 17.19. 20.31. 23.44. Oh yeah, pretty much. Bano ogata bagata. That is it. Oh yeah, they can't let you go. Let's get the other, the total here. 1.56.
6.25.
6.25. Keep going.
14.06.
14.06.
25.
You said? This is 29 or 39? 39.06.
06.
Huh? Then 50.
56.25.
25. Keep going.
76.56.
0.56. Yes.
Yeah, 100.
And this will be 100.
Yeah.
Okay. But like I told you, when you round off, you'll have an extra figure. Most likely, you may get like 101.2 or 100.26. The effects of rounding off. So keeping two decimal places keeps you in check. Okay? Good. Now, listen. This is a unique curve where percentage cumulative frequency goes on the horizontal. It is the variable cumulative or value, percentage value, okay? Percentage cumulative value on the vertical against percentage cumulative frequency, okay? So I could have written this like this, percentage V. And I take this as, percentage CF. So we are going to have this as our Y, and then this as our X. Okay? Now, how many? I may need a bigger, no, this will be enough. I need to mention this. Because a Lorentz curve is a cumulative frequency curve, it starts at the 0, 0 mark. Okay? It never hangs. It starts at 0, 0. Yeah, no. Apart from the last point, cumulative frequency curves do not touch the do not close, if I can say it that way. It starts at a 0, but it goes and hangs within. They never close. Yeah. Oh, I just wanted to show you something. You remember what we did yesterday? The way it links to probability. I think it's the more than and the less than. You see these curves here? They create a steep right here. They create a normal distribution. You have your median here, okay? You'll have the mode as well here, because this is the highest frequency here for these two curves. And if you computed the mean, it will be around the same value. Okay? Yeah, they are not asymptotic. But you remember even those classes were just introduced? The 0 classes were just introduced. So it would stay here, and this would stay here. Okay, and then this comes in like that. The tails. Okay, it's how the normal distribution comes in. And hence the question that the measures of location that are
Francis, you are lost. We can't hear you.
Hmm? Okay, all right.
I'm sorry, I temporarily went off. So what I was trying to tell you is that the graph goes ahead to explain skewness. I have 2 hours. So I'm going to make a presentation. When we came from Tintale, they want us to finish up something. Submitting my colleagues for tomorrow. We are helping out on like they will say Francis Jango to Yambe. Yeah. So I'll be it's more or less like Probono. It's it has to do with the formalization of SMEs. So it's sharing what you know, what should be done. But let's see how much. Okay, so I was trying to explain this. Negative skewness would look like that, where you have the frequency here and then the variable x. Now the thing is, you see that I've drawn half of the distribution. That half is the more than cumulative. Sorry, less than? More. Yeah, the less than, the one that starts from the right. The tail is to the right. Okay, that is the more than. So, which value, how do we call a value with the highest frequency? The value with the highest frequency. The mode, so the mode will be here because it's coming off from the tip. And then the value that is always in the middle is the median, and our mean will be at the end here. So there is a distortion of the figures. They have moved away from the middle, they're now scattered. So hence, positive skewness. Under positive skewness, you have few items of a high value. If you are to look at this very quickly here, assume you're looking at incomes. This is 10 USD, 20, 30, 40, 50. And then here's a number of employees. If I want to know how many received maybe 50 USD, I'll draw a line, touch the curve, and then I come here. Those people were 3. Okay? Now, if I want to know how many received 30, I'll draw up to here. Let the curve come here. This is 6. So this would be 5. So you have few employees that received 50. And then you have very many employees receiving only 30 each. A skewness in the payments. I don't know if you get me. It is common in organizations where work is repetitive. You find that most of the people are doing repetitive work, so they're at a similar pay. And then the undersecretary and the like, they're getting very huge payments or remunerations. It's common that way. Or they bring in a consultant once in a while who supports them. But work is repetitive, so the payments will be lower for so many people and high for a couple of them. That is positive skewness. Now, negative skewness, you flip it. You have few items of low value. You see that? Again, you start with the mode here because it's the highest. The median will be in the middle, and then the mean. So this one is the less than. You see it? It is the right part of the curve. The one in blue, okay, is the negative skewness. So right here, you'll have few people receiving less and many people receiving more. When you look at specialized industries, let's say you are all professional accountants, okay? So you're almost at the same pay. So many people are receiving almost a similar check. Or let's say you were doctors, you're almost receiving the same check. It's a similar industry. People have the same apprentice. You get what I mean? And then the few people are probably support staff. They support the highly technical persons. You could have seen that with the medical industry. Okay, it is common. They are highly specialized people, and there are many in their industry, but they have support people. Okay. Now, for the normal distribution, that one is rare. It can be in industries where there is a mix, both technical and unskilled, and the numbers are almost the same. Okay, are almost the same. Okay, so I thought this graph would explain something about skewness and the normal distribution, just to draw a picture. Okay, that was a by the way. Okay, so guys, let's move in. On our horizontal, we are going to have the percentage cumulative frequencies. On the vertical, we shall have the percentage cumulative value. Okay, same thing. We don't have negatives here, so you don't need to include them. Okay, so it starts with a 0, 0. Now, tell me, for each of them, it is 0 to 100. Are we together? On the horizontal, what would be your scale? 10 for? 10 for 1 centimeter. Oh. Yeah. Yeah, they are 19, so you have like 18 available. On the horizontal. Yeah. 1 centimeter for 10. Okay. And then on the vertical, 2 centimeters, 10.
Yes, 2 centimeters, 10.
Thank you. 2 centimeters for 10. Perfect. Oh, so it will fit. I can do the same. No, it doesn't fit.
Press it fits.
No. You're good. You're good. Yeah, you're good. I'll do this. Okay. So now we start. This is the horizontal is percentage cumulative value. Oh, sorry, frequency. And the vertical is percentage cumulative value. Okay, you have to be really keen. So our X, we first read X, then Y. So we are going to read X as 4.35 and Y as 1.56. Okay? So 4.35, this is my 5. And then 1.56, I would assume it's here. Okay, my first point is at 0, 0. Okay? Next, we have, it's cumulative frequencies, guys. 13.05 and 6.25. 13.05, so 13 here. And then this is 10 for me.
Hello, Buzz.
Yes, please.
Just asking, in case I switch the figures, like how we have our V percent and F, and I just interchange them in case I've forgotten. Am I penalized?
That is to the examiner's discretion. That way, your graph will look like this. The bottom will come on top. It will look like this. You see the purple?
Yeah.
That's how your graph will look like. So the examiner is the one to take charge of that. It is to his discretion.
Okay.
So your graph will be upside down, the way you see the purple drawn. Okay? It will, we call it the ball. The lens curve will close into the line. Okay, so that is to the examiner's discretion.
Okay.
I don't know if I've really answered you. In other words, Francis, for you, what would you do? I would give a mark. Okay, I would give a mark if the explanations fit the visuals. Okay, next we have 27.18 and 14. 27.18 and then 14 is somewhere here. Next is 46.75 and 25. 46.75 and 25. Guys, your graphs should be better than mine, okay? And then I have 70.66 and 39. 70.66, 70.66, 75. Yeah, 70.66 and 39. Maybe I can put it here. Okay, and then 86.96 is actually 87, and then 56. 87, 56. 87. 56. That is 50. I'll put it here. And then 97, 76. 97, 76. And then 100, 100. Okay, yours should look better, okay, because you are near to scale than mine. Okay, so now we join. We join. Come again?
97,
90.
You've put it at 80 something.
97. Oh, yeah, this one. 97. Thank you. 76 should be somewhere here. Thanks for that. Okay, so guys, we join. I wait. No, just join the points.
97.8, 97.98, 98.
Okay. Then I'll let the line come through.
96, 98, 76, 95, 76, 96.
Yeah, the line is straight. It's a line of equal distribution. So that line should come from the 0, 0 mark up to the last point. Okay? Yeah, because it's a curve. Anything to do with a curve, if they had said Lorentz polygon, then I use a straight line. Yeah. Zero. It's 0, 0. This is the first point. 0, 0 is the first point. For all cumulative frequencies, okay, all cumulative frequencies start at 0. That's why we say if a class is not there, its cumulative frequency, its frequency is 0. So for payments that were not there, the frequencies were 0. Yeah, so all cumulative diagrams start at 0. Yeah, it's nice. That's something. Okay, get a graph. Get a graph. Whatever that is about you get this in this thing. But that's cool. So sometimes you may be asked to comment about the graph. You may be asked to comment about the graph. Oh, thank you. So to comment about the graph, this is what you do. Because when you look at this one, there is a bit of isolation. Should I call it isolation? Split. Between 0 and 40% for the percentage frequency, it is closer to the curve in this area. You see that? But later, it widens. They become unevenly distributed. So 40, 1, 2, 3. So 1, 2, 3, right here. These points are closer. Right here. Right here. And the discrepancy is less between balances from 0 to 200. Balances from 0 to 200, there is the balances are evenly distributed among the owners or account owners or card owners. But then from 200 to 800, the balances are widely scattered, okay? And that is picked from our graph right here. You see? When you look at purple, okay? It gets off the line of equal distribution. Okay, this is our line of equal distribution. I don't know if that is clear. Yes. They? They close it from inside. Oh, where they join up really doesn't matter. He's talking about this. Where is my 100? Okay. He's talking about this. And then that. That closure has nothing to do. Yeah, it has nothing. Yeah. What would have an issue is the Gini ratio where you have A and then B. So you have an angle here, which is 45 degrees. And the Gini ratio, but I doubt if you go through this, is A over A plus B. So the percentage occupied by the incomes, that analysis of the curve to the
Excuse
angle.
me, sir.
Yes, please.
What if you put the percentage cumulative frequency up and then the cumulative frequency for the value down?
Yeah, it is something someone asked, and I tried to draw it here. Oh, I think I rubbed it. What will happen is that your Lorentz curve will be on top. It will be that way. Okay? And that's why I was saying that the discretion now is to the examiner to either give you a mark or not. Is it okay?
Yes.
Because when this person flips it, when you put the horizontal to the vertical, when you turn your page, even this one can look like that one. Okay, here I've turned, but when you turn your book, you'll find that it is in the opposite. The ball is flipped, but still the way the axes are labeled still stands. Okay, so that is to the examiner's discretion, frankly.
Okay.
Yeah. But go by the standard. Sometimes he may not give you a full mark. Literally, he'll just mark the percentages for both axes, and then I'll try to award a mark for the curve. Okay?
So meaning?
But that's a literally what you'll have done. You'll have made y the x and x the y. That would be a mistake. You get it? Yeah. So just be keen. Like when I was starting, when I was starting, I told you it's a unique curve where cumulative frequency appears on the horizontal. Okay. Did someone have a query? Okay. Let's move in to the Z chart. The Z chart. That's the chart. That's the chart. So we are saying that this is a time series graph that illustrates come again? Yeah, can't I round off the points when plotting? Yes, you can. You can. I actually talked about it. Like for instance, it becomes hard for you to fix 1.56. Where would you put it? Okay, so you'll find that someone is drawing maybe 1.8 or 2. Okay. Or when it comes to 4.69, you draw 5. When it comes to 7.81, you draw 8. When it comes to 10.94, that is 11. 14.06 is 14. 17.19 is 17. 20.31, sorry, 90, and 90, the point you are plotting, sorry, I did the other side. 70.66 is 71. 86.96 is 87. 97.83 is 98. So you can round off. But here in the table, you are showing him the actuals, and we'll go by that. Okay? Guys, when you're doing an exam, also try to create an impression. Some people think it's only the answers, but an impression interests the examiner in your paper. Someone is tired, but it looks like the handwriting is like, then the answers are the ones to disappoint, maybe. But already the presentation says it all, that the guy is okay. When it comes to things like outline the importance of quantitative methods in the day-to-day business applications. And then the handwriting is not so clear, but the answers are okay. The guy will struggle. He'll start to underline words he shouldn't have. But when someone gives the first 2 points and they are clean, the next 3 might be just marked. Yeah, because the first 2 are clear. When he sees the key terms, he'll just give a mark. But the first 2 are not clear, then also the handwriting. Yeah, but I've seen people's handwritings are good. People write. Okay. So this is a time series graph that illustrates the original data, the moving totals, and the cumulative totals for the current period. Usually it considers annual values. It usually considers annual values. Okay. So we plot the time series values, that is original, cumulative totals, and moving totals against the periods. Okay, so we shall have something like this. You'll have the variable values, and then the period or periods. And then I don't know, I can represent it. I'm trying to check. You'll have something like this. Let me see if this allows me. Okay, it will. It will. And then oh, sorry. Let me use a different color. Oh dear me. I'm losing what I wanted. So. And then this will come through. And then I think this breakdown is too much, but it's just an illustration. And then you'll have okay, so that's how it looks like. The format is in a Z form. These ones here are the original data values, original values. These are the cumulative frequency. And these are the moving totals. Okay. Yeah, I guess so. So let's take an example. Oh, do I explain as you watch it? Yeah, I think. No, before the example, let's look at the procedure. The procedure. Okay, so determine the total of the prior period. Okay, then generate the moving totals for the current period. Okay. How they are generated. Do I need to explain that? I'll show it here. I'll show it here. Then compute the cumulative frequencies for the current period. Okay, then plot the original data, the moving the moving totals, and the cumulative frequencies against the periods. What is the basic graph here? November 2017, November 2018. Okay. So guys, I have two graphs here, November 2017. Francis, yesterday you said we cannot start with graphing. So if it is my best and it's what I see, can introduce me to the paper. You go with that. But you have to take your time. If a number takes you 10 minutes to do, a graph should take you 20 minutes. You're still saving time. You still have 10 other minutes. You don't rush a graph. Like for instance, if instead of writing, if I wrote 10, 20, and then after 20, I say 40, my entire graph is distorted. People have done linear programming, can testify. Linear programming, you lose one unit, and the entire graph is different. You introduce, let's say, a constraint that's not supposed to be there. You have a totally different graph. Yeah, so you have to be keen when you're doing graphs. So as you do, as you know, there's when you're doing another question, but your mind is still with the other one you just did. You're like, wow, did I put X? You go back and check, and then something is missing. To correct, you redraw the entire graph. Now that disturbs. That's why I said a graph can be your second question or third question. Yeah. Some people do it last. Some people do it last, so that by the time they say time up, is probably finishing the graph or doing the interpretation. Yeah. That's what I'm saying, that if you're comfortable, you go for it. I'm talking of where the entire question is a graph, like for instance, linear programming. All your answers are going to be determined by the graph. That's what I'm talking about. Yeah. I mean, such an instance, you just go. Okay. Here we go. Maybe we try, this is November 2017. It has some decimal points. Might be a good one. November 2017. Let me show it to you here. And then people, what the questions? Don't run away from them. Engage them. There was a number for chi-square, which the examiner put in words. People said, Francis, start all other words we didn't do. But I told you start with required. Okay, you start with the required. Identifying that? Oh, yeah. Actually, when it is worded, is trying to explain himself further. So he's giving extra details. Yeah, so you may use what you don't need because it has been provided. Yeah, I get what you mean. People like it when they say compute, differentiate. The table the table is drawn for you. That's what we would like to have. But the examiner wants to eat a bit of your time because it's part of the exam. And then also interpret, is trying to put more or less like a case scenario. Yeah. Which one? Yeah. No, they mark, when they are marking, they mark entries. Everything is marked, just know that. So among those things, if you had some issues, the issue will be marked wrong, and whatever is correct will be marked. Now, the final answer is what creates the challenge. You lose on marks for the final. If the final answer is 1 mark or 2, you don't get them. But you get marks for your procedure. Yeah. You get a mark for every computation you make. Yeah. Okay, so this is November 2017. Okay, guys, this is also what we forget, that even what we know is examined. Yeah, yourself. From AI to everyone. Okay, I think AI is watching. Yeah, yourself. Okay, may someone read, someone online, may you read that question for us, please?
The following data shows the turnover in million shillings of a chain of supermarkets in Kampala for the years 2015 and 2016. Required to construct a Z-chart for the data.
Okay, now in the exam, you first read the required. Is that okay? In the exam, you first read the required, so that as you read through, you'll pick out details you need. Okay, good, thank you. So this means these are years, and we said Z-charts are usually annual graphs. Okay, so let's move in. We are going to create a template. This is example. November 2017, 1B. So that data there is the turnover, okay? So we shall have 2015 turnover, 2016 turnover. And he said it is in what? It is in millions, I guess. So this is in millions. Okay, so now what do we need? We shall need the moving total. That moving total is for 2016. We shall need the cumulative frequency. 1 second. Okay. The Z chart is always for the current period. It's always for the most current. Okay, so when you are plotting, it's original data of 2016, moving totals of 2016, and cumulative values of 2016. Okay, yeah. Okay, so we're going to write them out. I have a 2.0, 3.5, 4.0, 4.2, 5.1, 2.4, 3.5.1, 3.0, 4.2, 5.2, 6.0, 7.0, and 8.2. So they go like that. Okay, down here, we shall need some total of sort. Come again? 54? Oh, you added, eh? Okay, 54. Oh, that total, I wrote it wrongly. This is 54.8. Okay, we fetched 2016. I got it 2.3, 3.8, 4.5, 4.6, 5.6, 2.5, 2.9, 4.0, 5.8, 6.2, 7.6, and 9.6. Okay, nice. So this one, you don't need the total. For it, you don't need the total. What you'll need is its cumulative frequency or cumulative total. I said cumulative frequency, but literally this is a total. Cumulative total. Okay, now the moving total. What I didn't do, I didn't put the months. Okay, but it's okay, you'll appreciate it. With the months, you would appreciate the movements. But still, it's okay because the examiner usually gives you the months, which you can indicate or not. Now, a moving total is more or less like a rolling value. Look at this. This total starts from 2, right? And ends at 8.2. They added 12. The next 12 they are going to add will start from what? This one ended here. The next total they are going to have is going to start from what? 3.5. Thank you. Up to 2.3. Are we together? And when you count 12, it's going to move from Feb of 2015 to Jan of 2016. Is it clear, guys? So now this is the thing. It means, and I want to explain it here. I'm sorry? Is someone saying something?
I'm saying it's not clear. I've not understood.
Okay, you've heard of moving totals and moving averages?
Yes.
Okay, it's what we are doing here. So our first total, this total here, 54.8, starts from, allow me to put the months. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay? So from Jan to December, we added from 2 up to 8.2. So from here up to there. Is that okay?
Yes.
Okay, now next, you are going to add, you add in 12. It's an annual total. You add in 12. We are going to add from Feb. Where will the next value be?
2.3.
2.3, which is Jan the following year. Am I clear?
Okay. Yes.
Eh?
Yes, I've understood.
Okay, now this is the thing. How do I get the next total without adding everything? Okay, so this 54.8 starts from number 1. Now, what we do, because we want to start from number 2, it will be 54.8. We take away the figure in number 1 and add back the figure in number 1 of the following year. Is that okay? That will be the next 12th figure. Have you understood? So the figure we are going to write in Jan of 2016 will be the 54.8 minus 2, add back 2.3. What do you get? It will be, you're adding 0.3. It will be 55.10. Is that okay? Guys, have you understood? Now, our next, once you do that, you don't need to keep adding 12 figures.
Pardon.
Come again?
Pardon.
What's your challenge? Tell me.
Moving totals.
Yeah, what's the challenge? What's not clear? That's what I'm asking. Please go ahead. I think she has gone off. Have you gone off or you're still there? Hello, the lady that was asking.
I saw someone leaving. Maybe she's the one.
Okay, whenever she comes back, she'll let us know. Okay, now the next one will be. Yes, please.
Where do you get the 54.8?
You see this? This is the one we started with. In our procedure, you are saying determine the total of the prior period. That's the one you start with here. The total of 2015. Let me show you something. This is a number line. Okay, so I have Jan. Oh, pardon me. I have Jan here. Or I have 1, 2, 3, and so on up to 12. Okay? This is 2015. Are you following?
Yes.
Then I have 1, 2, 3, 4, up to 12. And this is 2016. Now, if I want the first 12 values, the total of the first 12 is, kindly mute. The total of the first 12 is 54.8. That is from here up to there. Are you with me, please?
Yes, I am.
Okay, now I'll use the actual figures. In this was 2, this 2 here, and sorry, this is 2. This figure here is 2. And my first figure this side is 2.3. Now I'm adding in 12. When I drop the Jan figure, what is the 12th figure I should add on? Talk to me kindly. When I drop Jan and I have to add 12 figures, I'll start from Feb of 2015 up to?
The next year, I think it's 2016.
Which year, which month?
Yeah, 2016, January.
January 2016. So that means in this total of 54.8, this 2 is part of it. Remember, we added it there. So if I want the new total in Jan of 2016, I'll get the total 54.8. I take away the 2 and I add on the month I'm adding on. Is that okay?
Thank you.
I'm sorry?
It's clear. Thank you.
It's okay, good. So we are going to do that for each month. Now, our next, the previous total is 55.1. The next total is 55.1 minus what? Minus 3.5, add back. Good. What do you get? Thank you. What do you get?
55.4.
55.4. Okay. Do some people have some totals? We put them. Okay. What are they? 55.9, 56.3, 56.8,
56.8, 56.9, 56.9,
uh-huh,
56.8,
uh-huh,
56.6,
nice,
57.2,
perfect,
57.4,
nice,
58,
uh-huh,
59.4.
nice. If you want to proof check yourself that all those figures are correct, this is what you do. This total here, this total here is the sum of 2016. So you go back and add the turnover in 2016 and see if you get 59.4. That's the proof check. The last 59.4 is the total of the last 12 items. Your last 12 items are the turnover of 2016. Okay, so you just add it up and see. Okay, good. Let's get the cumulative total. Guys, ask when you have a challenge. So cumulative total is 2.3, he says. This one here, 6.1. That is this plus 3.8, you get 6.1. Okay, keep going. Come again? 10 points.
15.2.
Sorry about that, guys. I temporarily went off. Keep going. 23.8. Come again, brother. You read me 15.2, 20.8, 23.8. Keep going. 23.3. 26.2, 30.2, 36, 42.2, 49.8, 59.4. Okay, nice. And then that last cumulative value is again the total of 2016. Okay, if those totals are not the same, that's what I'm saying, you added wrongly then. This total here must match the last cumulative value. That's what I'm saying. If we had got something different from 59.4, they would have a mistake. Okay, so check one of your figures. Guys, these you can do self-checks. You just go back and check the entries. Yeah, so you check the cumulative value, okay? must be the total for this. Those three must be the same. Okay? Nice. Now we go to our graph. This graph disturbs in terms of scale, but it's one of the easiest. Okay? Disturbs in terms of scale, but it's one of the easiest. So fast forward, you must identify the least values. Your least value will happen in the turnover, in the original entries. That's where the least value is expected. And then the highest value is expected in the cumulative because you are adding them. Okay? Now, beauty is, what's our highest figure among what we should plot? 59.4. And what is the least amongst what we should plot? 2.3. Is that okay? Good. Now we come to our scale. The horizontal is clear because for the horizontal it's months. Okay? The vertical scale is a mix. So tell me, on the vertical you have over 26 centimeters. 5. Come again? 5 for each. I've not understood, brother. For every 1 centimeter, it will be 5. And then that's vertical.
Vertical we can use.
Horizontal, it will be 5 for 1. Is that okay? So we are using 5 centimeters for 1.
2 centimeters for the vertical.
That's the thing. When you do, if 1 centimeter represents 5,
it will be so short.
If 1 centimeter represents 5, it will be short. So you can do, you can do
2 centimeters.
2 centimeters. Just you are saying 1 centimeter to represent 5. You'll be using 12 centimeters.
Nah.
1 box represent 5. That's the thing.
No, 2 boxes, 2 centimeters to represent 5.
Okay, so someone is saying 2
sir.
centimeters represent 5.
So I kindly, I want to see the table. If you could scroll it down a bit. Yeah, there
you go. Sorry. Okay, you are saying it's a nice thing. So what you do, you actually tag the figures there. You say 5, 10, 15. It will be small. To represent 5.
Yeah.
Thank you. So you should utilize at least more than half of your graph. Okay, good. Horizontally, use 1 to represent a month. 1 centimeter to represent a month. You get what I mean? Okay. So guys, I hope it's clear. Let's move in. Come again? No, you see for real, it is 0 to 1 and 0 to Jan. I'm going to show you a time series graph is a bit different. I'll show you.
Okay. You're done.
Okay, so no. So this is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and then 60. So this is our time series. Or you can say, you can call it turnover, right? That's turnover. And then on the horizontal, there are months. Now, you don't put the month at a 00. A time series is recognized at the end of the period. So I know this is going to disturb me, I guess. So this here is Jan. Jan starts from 0. Where I've put the J is where the month ends. And then another one starts. So that is Jan, Feb, March, April, May, June, July, August, September. Okay, I'm having that challenge, but I'll compromise it this way. This is Jan, Feb, March, April, May, June, July, August, September, October, November, and December. Okay? Now we start. You start with the original data. Okay? Now with you, your graph is really nice. You are saying that for every 10 centimeters, 2 centimeters, you have a unit. Each small square represents a what? A 1. Are we together? So when it comes to this, okay, let's plot. Jan of 2016 is 2.3. So you come here. Jan, for me, this is 2.2, right? Sorry, 2.5. So my 2.3 is around here. You see that? I guess for you, you can see what you need on your graph. So 2, you are going to go to the next box and put the 2.3 in the middle. Every one small square for you represents a unit. Oh, okay. Okay. For every 2 centimeters, you were writing 5. So that means 10 boxes are representing 5 is 0.5. Yeah, so it will be easier. Is that okay? Okay, so we move in. So for 2.3, you are going to have 4.5. So 4.5. Four small boxes. Right? Okay, so for Feb, I hope guys we are clear. For Feb, 3.8. So Feb is 3.8, this is 2.5. So 3.8 would be somewhere here. Okay, it's not really exact. And then for March, then you draw for, you try to, to have a two. You want to do what is easier. What you do, you try to approximate closer. Yeah, you get closer. You may not do it exactly. To show the examiner, you know what, I'm estimating. These are estimated values. Okay, 4.5 is in March. 4.5 in March. And then 4.6 in April. 4.5 and 4.6 are close. Then May is 5.6. 5.6 in May, which I'll put somewhere here. June is 2.5. 2.5 is exactly here. July is 2.9. 2.9 should be here, right above 2.5. Then August is 4. August is 4. If this is 5, I'll put 4 here. September is 5.8. September is 5.8, which I can put somewhere here. October is 6.2, which is somewhere here. November is 7, which is somewhere here still. And then December is 9.6. 9.6, we go all the way. When you are joining these, you join with a straight line. Okay, you join with a straight line. So here my straight line goes. Okay. No, it starts at Jan. Okay. The time series observed at the end of the period. So literally, you'd be doing this. You'd be coming from here. Okay? But it starts where at the end of the month. Where you wrote the month is where it ended.
Excuse me, Buzz.
Yes, please.
You're plotting, because I'm having a different graph. I think I've made a mistake somewhere.
Come again. We are plotting the turnover for 2016 against the periods first. Is that okay?
No.
The turnover for 2016 is here. This one here is what we are plotting first against the month. In Jan, the turnover was 2.3. That's why we are here. In Feb, it was 3.8. That's why we are here. Is it okay now?
Okay, yes.
Okay, sounds good. Okay, guys, next we are going to do the cumulative frequency or the cumulative total. Okay? So the first cumulative total is 2.3. Okay. We continue. So sorry, pardon me about that. So 2.3 on the vertical, I'm here. My next in Feb is 6.1. Do you see that? 6.1, I see you are ahead already. 6.1, I would put it here. March is 10.6. 10.6, 10, this is 10.6 is around here. April is 15.2. April 15.2, this is 15, I'll put 15.2 there. May is 20.8, 20.8 around here. June is 23.3. June is 20, 22.5, 23.3 is around here. July is 26. July is 25, 27, 26 should be around here. Then August is 30.2. August 30.2 is around here. August, September is 36. September is 36, 35, 36 is around here. October is 42.2. October 42, this is 40. 42.2 is around there. 49.8 and 59.2. 49.8, 47, 49 is close to 50. And then 59.4, 59.4, close to 60 right here. Okay, again, we use a straight line to join up. You join point to point, right? So they may not necessarily be all in a straight line, but point to point, you are using a rule. And then this one here. Okay, hey, people have left us. They are doing the moving total. Okay, now we go to the moving total. The moving total 2016, the first one is 55.1. That is for Jan. Okay, 55.1. So my Jan will go all the way. 55.1. 55 around there. And then Feb is 55.4. 55.4 is around here. That is Feb. March is 55.9.
Excuse me, Bud.
Yes, please. 55.9.
Sorry, me, I'm a little behind.
Yeah, go ahead.
That's second graph. We are plotting what?
We are plotting the cumulative frequency. These ones here.
Okay.
Yeah.
Okay, thank you.
Okay, so you're welcome. So Jan is 2.3, 6.1. Okay, sounds good. We have gone as far as March. We go to April. Let me know, guys, wherever you are stuck. April is 56.3. 56.3, mine would be around here. That is April. Mine is 56.8, around here. They're all almost the same, okay? But there's little changes. That was Jan, Feb, March, April, May. May was 56.8. June is 56.8, around there. June is 56.9. July is 56.8. 1, 2, 3, 4, 5, 6. 56.8 around here. July, August is 56.6, which is around here. August. September is 57.2. 57. This is 57.5. So 57.2. Would be here. And then 57 point, 56.2. Yeah. And then 57.4, which is almost similar. 58. So 58 goes a little above this. And then 59. So we join the points. It should be a straight line, point to point. There you go. Does someone have something like this? Okay, hence you have the Z chart. Oh, come again? What? Yeah, it's for observation of trends. They actually ask you to explain, to do a little interpretation. So what you do, you come to periods where you see distinct changes. Like for instance, you can say in the year 2016, the turnover, okay, gradually improved from Jan to May, right here. You see that? and then there was a drop between the month of May and June, and then a recovery thereafter up to December. So you can pick trends of a specific area, okay? And then, I don't know if you see that drop in the cumulative frequency. You see this? That one corresponds to that. And then also when you go in the moving totals, it will be depicted. I guess you can see something here. You see that? So for each graph, those areas are picked. So you choose which one to really explain. No. It's a graph for interpretation or physical interpretation of not necessarily data spread, but trends, because it's a time series graph. It's a time series graph. And actually, that's one of the things I'd like to see. How do you generate a time series graph? Okay, so guys, this one looked like this. There is when the examiner gives you huge values, but you should know how to compress them. I guess that was in November 2018. Let me see. You have a question, sir? What is the title of the graph? Okay, let's put it. But just a second, November 2018. Mugenda kumbuza ebibuuzo kyenjagala mufune kimbule. November 2018. Yeah, November, yes, on the y-axis, I want to plot first the current data, then cumulative data, then, yeah, this graph, you can start with anything. You choose, okay? You choose to start with anything, depending on what, how your data is organized. You can choose to start with anything, okay? So we can say that a Z-chart a Z-chart of turnover against the months.
Hello.
Yes, please.
The last one you plotted what?
Oh, the last one. Oh, let me indicate. Blue is cumulative. I forgot. You do this in the exam as well. Cumulative totals or cumulative turnover, actually. Cumulative turnover. And this is original turnover. And this is moving totals. Turnover again. Or you can just say moving total, cumulative total, and then original turnover. A cumulative turnover, original turnover, and then moving turnover. Yeah. Yeah, that's okay, because it's all turnover. It's either a moving total, original values, or the cumulative values. Yeah. You start with any you want, but that should be the final result. Yeah, you start with any you want. Okay. Yeah, please. Yeah, and that's what I was trying to look for. I was trying to look for a question. Some large numbers would be a challenge. Like for instance, if your graph is starting with 1,000, And most values are within the range of 1,000 and 1,020. I don't know if you get me. You see, for this graph, we are chanced that the lowest value is 2.3. And 2.3 really fits in the scale 5. But just imagine your values were running from 1,000 to 1,020. Are you getting me? What it means that between 0 and 1,000, you don't need anything. I'm going to show it to you here. If our values were starting from 1,000 to maybe 1,020, actually, what's the difference between 1,000 and 1,020? It's only 20. Your still should cover just 20, not 1,000. So what you do, this is what you do. I hope you are getting me. Okay, so this is what you do. Of course, on the horizontal, they are going to be the periods. Now, on the vertical, I'll come here and do a zigzag. When I do a zigzag on the vertical, I say 1,000. It means everything from 0 to 1,000, I don't need. And then my scale caters for 20. I have over 26 centimeters. So every centimeter is a cell. So I'll read 1,000, 1,001, 1,002, 1,003, up to 1,020. Is it clear? Okay. You may have your lowest value as 800, and the highest is maybe, because you have cumulative values and the like, so it goes up to 4,000. Okay? Again, same thing. Between 0 and 800, you don't need anything. So ignore it. Okay? And say it is zigzag 1 centimeter up to 800. Okay? Now, it is not that when I have a zigzag on the vertical, I should have a zigzag on the horizontal. No, you don't do that for the periods. Unless your period is starting from June or July. You do a zigzag and then have from that zigzag up to July. Like if it starts from July, I'll do this. Zigzag, okay? This is Jan. That's July. This would be July. You see, the time series, where you put the period, it's where it ended. So actually here I'll put my. If it starts with July, okay, this would be June. Where the J is, June has ended. So when I write a J here, it is where June ended up to July. So this period here is a July period. I don't know if you get me. So when I say zigzag, June, it means June ended. From Jan to June, I needed nothing. Now June has ended, and now I need July. Yeah, so that's what you would do. Does it make sense? Okay, so for these big figures, it means my range is 3,200. So the question is, how do I fit 3,200 against the 25 or 20? So you may use divisibility. You may say, if I take for every 5, I do 100. How much will I need? 160 may disturb you. Try to use multiples of 500, 1,000, 100, 1,000, and 500. Those multiples. So if I took 1 centimeter to represent 100, will I do that? No. If I took 1 centimeter to represent 500, What is 3 to divide by 500? 6.4, so I need like 16 centimeters. So I can say for every 1 centimeter, let me use 200. For every 1 centimeter, it will be 200. Then I'll have 16 centimeters to move from 800 up to 3.2. So you play around with that. Sorry, up to 4,000. Okay? Yeah, so it will be 800, then 1,000, 1,200, 1,400, 1,600, and so on. And your figures will be captured. Okay. I would like us to look at a time series graph quickly. A time series graph where they tell you compute the trend values and hence construct a graph with the original values on the same graph. Construct a graph together with the trend values. Okay, very quickly, we are going to use the same methodology here to do it. Yeah, need to change. Okay, and that one straight away, we are going to use June 2015, I think. Yeah, June 2015, question 2. Did I do interpolation and extrapolation? We did? Yeah. Okay.
Sir,
Yes, please.
after this, can you help us with Kendall's?
We did Kendall.
Oh, I was absent.
Banai, are we in a break? What's happening? Dan asleep. You'll sleep after Tuesday. Tutuufu. Pepa tugitya naye tutya kati awo oyagala nneebakye ngugumuke nga nneekanga.
Okay, guys, pardon me. I temporarily went off. Sunday. Okay, so this is June 2015. It's just a continuation of the time series graph. So June 2015, question 2. Question 2, part C. Okay, this is the question. So it says that the following table shows quarterly items sold by a company over 3 years in 10,000 units. Okay. So compute the four-centered quarterly moving averages, then plot the original data and the four-centered moving averages. That's my major question. I know the rest you know how to compute the centered and the like. Okay. So let's move in there. So first, we need the four-centered quarterly moving totals. We shall arrange our data.
Which sitting was that?
Come again?
Which sitting was that?
June 2015, question 2. June 2015, question 2, part C. So we have the year, we have the quarter. To get the trend, the four-centered quarterly moving averages, that's the trend. Remember what we said, that for even data, the centered averages are the trend values. Okay. So you'll have quarterly items sold. So items, or units, you may say that. Then we have the moving total, the moving average, and then the centered average, which is the same as the trend in this case. Okay. Okay, so the first year is 2010. We have quarter 1, 2, 3, and 4. 2011, quarter 1, 2, 3, and 4. And then 2012, quarter 1, 2, 3, and 4. Okay, the items, this was 60, this, keep going, 142, 87, 79, 120, 163, 94, 84, 131, 297. Okay, perfect. The rest it is us to generate. So it's a 4 point. When it says the 4 quarterly, they want the four-centered quarterly. So we are going to be adding in 4s. Okay? So the first 4 are 1, 2, 3, 4, 60 up to 87. But that should appear in the middle. The middle of the first 4 is between 2 and 3. What total do you get? Yeah. 293. Are we at par? We are now dropping 60 and start from 104 up to 79. Are we clear? So that means you'll do 293 minus 60 plus 79. What do you get? 412. Perfect. We drop 104, start and add back 120. So 412, just a second, 412 minus 104, add back 120. What total do you get? Just a second, please. 128. 428. Please go ahead. The lady asking.
I was begging your pardon on moving
On which one?
how we are computing.
Okay, you remember how we computed the 12-month turnover? The turnover here? It's the same thing. Okay, let me take you back. Follow my blue. Can you tell me the first four, please?
It is 60, 104, 142.
You are too fast.
87.
You are too fast.
60.
You said 60. Go ahead.
104.
104.
142.
142.
And 87.
87. Can you add that for us? Toina calculator.
Where I stay, we don't have power, and my calculator, I misplaced it.
You misplaced your calculator?
So when you add those four, you get 393, not 293.
You get 393.
Yes.
Yes.
Oh, okay. 393. 393. Is the next one 412?
Yeah.
Okay, sounds good. Okay, but the lady that asked why you correcting or not to correcting?
Yeah, we were there before.
You are correcting it?
Yes.
Okay, is it why you were wondering how we are getting the totals, or you're now okay?
Yeah, I'm now fine.
Hey, okay, fine, good.
Thank you, sir.
Okay, thank you for that. Thank you. Okay, so the next one. The next one we are dropping, what did we drop the other time? We are dropping 142, right? And adding back 163. That total should appear here. What do you get?
449.
449. Okay, drop 87, add back 94. What do you get?
456.
456. Drop 79, add back 87. That total will appear here.
464.
464. Drop 120, add back 131. That total should appear here.
475.
475. Drop 163, add back 200. That total should appear here.
512.
512. Drop 94, add back 97.
515.
515.
Yeah.
Yeah. Now, just a second. Let's have proof check. For us to proof check, we add the last four. They should give us 515. Now, guys, when we drop 84, we have nothing to add on, so we stop. Okay? You stop when you can no longer add 4. Now, add these, see if you get 515. If you don't, then we made a mistake somewhere. Okay? It's just simple. If you don't get 515, you have a mistake somewhere. 512.
Yeah.
Okay, so which figure has a challenge? From?
464.
Where we, from 464. Okay, kindly correct us.
It's a
Okay.
461.
It will be 461. And then next? 472. 509. 512. Now add and see. Add the last 5 and last 4 and see. Okay. Guys, quickly, let's get the average. Average is total divided by what you added. Okay? So we're going to divide by 4. Okay. Can we divide to 2 decimal places? 98.25. You keep it where the total is. Keep it where that, because it's the average for that total. 103. 107. 103. 12.5. Keep going. Come again? Oh, 112.25. Thank you. 114. 115.25. 118. 127.25.
Excuse me, sir.
Yes, please.
I'm requesting for your pardon on how they get the moving average.
128. Okay. Let me ask you. You tell me this. I have scores as 50, 80, 90, and 75. What's the average of this?
60, 80 plus 90 plus 75. 152.5.
152.5. That's the average.
Yes. I've got
When
the
you
total
added,
and then divided by 2.
You divided by?
2.
How many items did you add?
4.
So why did you divide by 2?
76.3.
76.3 or 25. I'm sorry, the lady. Is it clear?
Yes.
Her average is
Excuse me, Mr. Baz.
total value over number of items. Is it okay? So to get 3993, we added 4 items. So to get its average, we divide by 4. Does it make sense now?
Yes.
Excuse me.
Okay, perfect.
Excuse
Now,
me, Mr. Baz.
guys, when we talk, yes, please.
Is it a must I should write the moving average in the middle, because I see the answers you've written the digits in between, in the middle of the line.
I want to explain something called centered. You know, when you say to center, it means you fit the value to a period it relates to. Okay? And let me just give you a quick a quick illustration. Are you appraised where you work?
Yes.
You have an annual plan, but they appraise you every afterward.
After 6 months.
Thank you. So your appraiser or your supervisor has split your work into two. That every after a half, midway the appraisal period, he checks what you have done. You get what I mean?
Yes.
So this is the same thing. When you are observing a time series, remember, a time series is nothing other than the sales you are looking at, other than the cost you are looking at. So midway the period of the time series, you stop to observe performance. This time series is 4 quarterly. Okay, it's a 4 quarterly time series. Meaning every after 2 quarters, you must observe what has been done. Are you getting me?
Yes.
So halfway the first 4 periods was between quarter 2 and quarter 3. That's why we placed that total there. Does it make sense?
Yes.
Now, we need to center. When you have even data, this average here must fit, okay, for all time series, it must fit within a specific period. What do I mean? If I asked you to tell me, is this value in the second quarter or third quarter? Where would you place it?
I'll place it in the second quarter.
Why the second?
Because it's a 4 moving average.
Okay, so it's not yet centered. You need to center it. That's the essence of placing them in the middle. But if it were odd data, if we are adding in threes, midway would be the second quarter. Are you getting me? So when you have even data, you put it by the borderline. That's what we did. What some people do, they leave a line in between, so it will go into a line. But we need to center it. So let's see where it goes. That is the essence of centering. Centering occurs when you have even data. So centering literally means that you want to relate the average or the trend to a specific period. So what we do, because these are not centered, literally a moving total would be the trend. But for even data, it's not, because it's not yet centered. So we need to center the averages. So what you do, you add these two and place the figure in the middle. When you place the figure in the middle, midway those two is going to be in the third quarter, not the second. I'm sorry, have you understood? I tried to compile everything in one sentence, most probably. But do you understand it?
Yeah.
Okay.
Yeah, it's clear.
So let's add the 2. This time when you add, you divide by 2 because you've added 2. Okay, what do you get? 2 decimal places.
149.75.
149. No, that can't be an average. That is too big. It's bigger than what you added. 100. 100.625.
Yes, I had made a mistake. That's the answer.
Okay. Then next, it is also moving. Okay. So we add these 2 and divide by 2. It is 105. And then these 2 and divide by 2. 109.625. Good job. And then these 2. 113.125. And then these 2. 114. 0.625. And then this 116.25. 625. Okay, and then these two 122.6 what? 0.625. And then this 127.625. So these are the trend values. They call them centered or trend values. Even odd data, there will be trend values, but for it, you don't compute the centered because they're already centered. You got it. The moving average for odd data, yeah, becomes the centered or the trend. Okay, it's the same. Thank you. Okay, guys. Now on plotting, I may just illustrate. On plotting, I don't know if you see what we were talking about. The trend values are between 100 and 127. So you are literally plotting 27 units. Okay? But then the original data has figures up to 200 even. So that means you are covered. Here you're going to plot the original data together with the trend values. Okay. Yeah, it goes on the X. No, on the vertical. Always on the X, it will be, remember, X is your periods. And the X value are the periods. So that means even here, there will be the periods on the X-axis. The quarters. You put the least unit of the period because here you have years and quarters. So the least unit of a period is the quarter here. There is when you may have months. Okay, so depending on what you ask. Yeah, please. Come again? Yeah, it behaves like a Z chart. Each chart. The Z chart is a time series graph. Okay, so let's see. Let's see how it goes. Are you guys busy tomorrow at about, I think in the evening, I don't know, 7-ish? I'll try to be home by that time.
We are available.
So I can do a control chart with you.
Please do it.
A mean range chart and
Proportions.
a mean chart, a range chart, and a proportionate chart. Usually
Yeah.
it is the mean chart and the range chart. Because I see tonight I may not be able. And then when I have an opportunity, we also do indices. I know I've stretched it. Was supposed to meet on Wednesday, but I couldn't, for sure. If I told you I was going to come, I'd be here like at 8. It would be really hard for me. Yeah, so it's like to compensate for that little time was supposed to have on Wednesday. So I don't know how it feels on your side, guys. I would like to do fully online. I may not be here. So depending, I don't know if it will be okay, but let me know if it can be. I can try to create that time. I'll communicate to the admin, see if they can create space for us on the links. Okay, so here we go. Please, I'd like to know your view, but even if I have 3 people, I can do it. Yeah, I just need like 3 people minimum. You will? The end time between 7 and 9:30. Yeah, that's when I should be done. I didn't move with them. Actually, I didn't bring them because I crossed from where I was. So can I drop them tomorrow? Tomorrow, Sunday is perfect time. I can drop them on Sunday in the morning. No, but I'll drop them here. Oh God, it's so absurd. Oh, then you never pass by here on Monday? Okay, then I'll scan, because scan they charge me. I can scan them and forward them. No, like I forward to individuals. Yeah. You people who were here were 8. But I'll make sure I'll bring them to Andrew, then he does a scan and send me. I'm really very sorry. Yeah, because it was really on my mind. Yeah, you need to see it. You need. Yeah. I'll make sure you get them. I'll make sure you get them. Okay. It's too bad you do a paper and you don't get the results. I need to bring them. Okay, so we do the same thing here. We have the different quarters. So on your horizontal, you're going to use only 12 centimeters because there are four quarters in each year. Okay, so you'll have Q1. Guys, notice how I'm writing them. I write a value not at the 0 mark. After 0, I write 1, okay? Then we got a 2, a 3, a 4, 5, 6, and and 10. Let me redo. Yeah, yours will fit. Mine won't. So 1, 2, 3, 4. And then 1, 2, 3, 4. And then this is 1, 2, 3, 4. 1, 2, 3, 4. And then 1, 2, 3, 4. Okay, so the years were 20 what? 2010, 2011, and 2012. Okay. Someone is saying, hey, yeah, that's it. You got it. Okay. Now we come to the data set. In our data set, we are plotting the items and the centered averages. Okay, the items and the centered averages. Come again? The items go up to 200. So the highest value is 200, right? And the lowest is? The lowest is 60. Okay? Now, this is the thing. Between 0 and 60, you have no activity. Okay, so we shall do a zigzag. And you may decide to call it 50. Okay? Because if this is starting, if our first value is 60, you would like also probably to stretch it. Okay? So you may call this 50. Okay, so from 50 up to 200, not so? From 50 up to 200, how many units are there? It's about 150, okay? So you may decide to use 15 centimeters, where for every 1 centimeter you have, So on the y-axis, do you plot moving averages or trend? It is the original data. The guy asked you the question. It is here. Okay? You should have, he's telling you, plot the original data and the percentage moving averages. So on the vertical, you should have the percentage and the original data. 1 centimeter to represent 10. So every after 1 centimeter, it's a 10. Okay. The person that asked that was a good question, please. So for every, okay, this is what you are plotting, and I think I circled it. You are plotting the items and the centered averages. So you need to check the lowest figure and the highest figure in both. The lowest figure may be in the centered averages or in the original data set. So you just have to be keen. The same thing to the highest. Is that clear? Okay. So for every 1 centimeter you have a 10 up to 200. So he's telling us this would be 60, this would be 70, 80, 90, 100. Okay? Then I have 110, 120, 130, 140, 150, 160, 170, 180, and I'll put 200 here, just for the sake of, at least you get what we meant. Okay, so quarter one, you are starting with the original data. Quarter one goes with 60. It will be here. Quarter two goes up to 104. Quarter two goes up to 104. This is 105. 104 would be there. Quarter three goes with 142. 142. 142 is here. Quarter four, 80, 87. Somewhere here. Quarter one, come again? 79, close to 80. Quarter two, 2011, 120, you said. Quarter three, 163. This is 165, 163 here. Quarter four goes up to 94, down here. Sorry, you are first. Quarter one, 84. 84 here. Quarter two, 131. Ngozi tuwanga yagala okugenda. 131. Quarter three, 200. Quarter three, 200. And then you said 97. Thank you, sir. 97. So we again join with a straight line, point to point. Okay? So you follow the order. This goes here. And then it continues. Continues here. then comes back. Okay, then I think the next point is this, period to period, guys, don't forget. And then this. And then it goes here. Then it comes back to pick this one. Okay, then with this, then comes to pick this. Then it picks this. Then this. Where do you read from? Which one? The private reading. Come and read from here. There is space. Over the weekend, even discussions. People hold discussions from up there. Yeah, over the weekend. Eh? No one would do what? To read? No, I mean you doing your private final touches. Yeah, the lady brings lunch here. But you buy it. So it's a conducive area. Eh? Hey, there's space here, there's upstairs. It's all, I mean, you have space. Please.
But then okay. We don't buy it, we also come physical.
No. Mugula, food is at 5K, it starts at 5K, so. Please find time, yeah. Okay, now we go to the trend values. The trend values start from which quarter? They start from which quarter? Come again. Quarter 3. So 100 is going to correspond to quarter 3 in 2010. 100.3. So you come here, quarter 3. Do you have a figure there? You don't have a trend value. So where you don't have it, you leave it. 103.
Sir, excuse me.
Yes, please.
Sorry, take you back. I am trying to appreciate this thing. So this question said original data, that's fine. Now the four-centered moving averages. My confusion is in the two. Four-centered moving averages and then centered, I think, values or trends.
Oh, okay. This is the thing. When the data is even we mean the guy says determine the four quarterly trend or moving averages. Determine the 6 quarterly trend or periodic or moving average. This is even data. That's where they use the word centered. And the reason is simple, that when you compute the moving average, the averages are not relating directly to a given quarter. A lady had asked, when you look at 98.25, you cannot relate it to any quarter. It is in between quarter 2 and quarter 3. So it needs to be centered. It needs to be attached to a specific quarter. That's why you go ahead to compute what you are calling a centered average. The centered average will take that other average into a respective period. That's why our first value, 100, has been centered in the third quarter. I don't know if, brother, that explains what you needed in brief, for sure.
Clear. Thank you very much. Thank you.
Okay, good. Now, a perfect example, if I can make it even clearer. This is the thing. If we had odd data, and I have cells 50, 60, 70, 80, 90 in my quarters, or in my periods, maybe months. Okay, and the guy is asking for a three monthly moving total. Okay, I'll add in threes. Brother, can you help me? The first 3, what total do you get? The gentleman that had asked.
180.
180. We drop 50, add 3, 1, 2, 3.
210.
Is it 210?
Yeah.
Thank you. We drop 60, add 1, 2, 3.
We drop 60 and add 90, right?
Yeah. That's what, 240?
Yeah.
Now, you realize that for a 3, when you were putting them, the 180 had to go in between the middle of the 3 is in the second month. So that one is already centered. So if you compute the moving average under odd data, it is equal to the trend or the centered, because it is going to be attached to a specific month or period. Do you get what I mean?
I get it.
Good job. So this will be 60, 70, and 80. Hope it's clear, brother.
Yeah.
So for odd data, the moving average is the trend or is the centered average. Under even data, the centered average, which is the trend, is an average of the moving average, so that you center the moving average. Okay, sounds good, brother.
Thank you.
You're welcome, sir. Okay, so guys, together, our trend values start in the third quarter. Okay, so that's where we start from. That is 100.625. And then we have 105 in April. 105 in April. Sorry, yeah, in April. 105 right here. Geno, right? It goes on the line for me right here. What do you have in Jan? Jan of 2011? The trend. 109. 109 would be here. What do I have in Feb? One what? Come again? 113 in April. Okay, then, sorry, that is in Feb. In March, what do you have? 114, a little, 114 around here. And then in April, what do we have? 116 around here. In Jan, what do you have? 2012? 122. 122 would be around here. Yeah, 1 to 2, you said. Oh, it's all the way. 1 to 2 should be somewhere here. Okay, and then in Feb, 1 to 7 around here. So we join these with a straight line. I'll use blue. And that's it. Okay, so this one here would be the trend, and this would be the original data. Sometimes people are forced to write on it. This is the original data, and then you put trend here. And this is it. We would say a time series graph, of cells. I think there were cells against quarters.
Can we draw the graph in pen?
Come again? No, the graph is in pencil, brother. The graph is in pencil. It's the writings that you put in pen. Okay? The graph is in pencil. Common mistake. Something with time series. I may not have all of you tomorrow, but this is something I'd like you to go with. That was September 2022, right here. That question, where we introduce correlation and regression in time series. Okay, was it in this sitting? How come I can't see it? Yeah, there you go. Guys, once again, for time series, the X are the periods. So here, the guy he was talking about 2 weeks. So you'd have the day, and then you have the cells. So you index, usually the examiner even tells you right here, he says index. So the days would run from 1, 2, 3, 4, 5, up to 14. Then put the different cells. This is your X and this is your Y. Indexing is you do a count. You see, when, no, yeah, continuously. You remember index number? And if I was number 1, you'd be number 2, you'd be 3, 4, 5. So when you index, you don't stop. It goes on and on for that data category. When we are in year 1, we are indexed from 1 up to the total number of the group. So it's a continuous count for index. Yeah, really. In other words, it's out of 100%. You count the entire data set. Yeah. Okay, and then sometimes they may present periods as years, 1990, 1991. Don't be forced to square these years. You'd be counting 1, 2, 3, 4, and so on. Okay, mainly for your time series questions. Yeah. Can you index? Yeah, so here the trend values were the moving averages. Yeah, they were the same thing. Can you? Yeah, so probably he thought he had asked even data, but this was odd. Okay, can you index quarters? Yes, you can. So in our example here that we just did, if we were to use a time series to determine maybe Pearson's product moment or the least square regression line to determine that trend line. Okay, so you would say 1, 2, 3, 4, 5, 6, 7, up to 12. That would be your X, and the cells would be our Y. Is it okay, guys?
Yes.
Okay, sounds good. Guys, by God's grace, tomorrow we should be meeting. I'll try my best to be on by 7. I think I don't have whatever it might be. Tomorrow is Saturday. Yeah, I'm closing the. Yeah, it will be a field. No, but I'll communicate. I'll communicate. Just know between 7 and 8 we should be meeting. So Andrew will send through a message and we shall get it. So I'm going to inform him. But temporary, it is 7. So, but between 7 and 8, I should be meeting with you, probably for 1.5 or 2 hours, and then we close it. Yeah. Guys online, please, I appreciate your time. Thanks for attending my class. Have a good night. Yes, please.
For the time series graph, do they always indicate what they want you to plot against? Because the question we did, he said original data and the centered average. Does it always indicate for such a question?
Okay, thank you. A trend value is the same as moving averages. I've tried to explain that, Oliver. I said for all the data, the moving averages are the same as the trend. For even data, the trend is the same as the centered moving averages. I hope that helps. So here, this is the trend, which is the average of the moving averages. For all the data, it is the same as the moving average. Okay. Sorry, the person that was asking last, what was the question?
The question was, like for a time series graph, will the examiner always indicate like what you're supposed to plot? Because for that question,
and in most cases, you are plotting the original data together with the trend. You cannot check a trend when you don't have the original values. Is it okay?
It's okay. I just wanted to know if that's how it always should be.
Yeah, that's what it should always be. Yeah, he'll do that.
Okay.
Yeah.
Thank you.
You too. Thanks for attending my class. Bye for now. Sir, are we meeting again at what time? Okay. So tomorrow around 7, you'll receive a message. You'll receive a message from Andrew. Between 7 and 8, we should be meeting. Just for me to do control charts. Yeah, to do control charts. And if I identify something. Yes. Oh, PM. AM would be okay, but people work, so it will be PM.
There is this question,
Yeah.
December 20, June 2012 question.
AM, people can wake up in the morning.
Yeah, no one is going. Only you have a paper on Tuesday.
No, let's do PM.
No, PM is okay.
Some people are working.
Yes, I've been practicing. This series question, dispatch to what does it mean?
Find out whether there is any statistical evidence to suggest that.
I did dispatch. I don't know if I did it right. I did this. Like, I think we're given the ranks already.
Yeah.
So I got this as the small r. But what does this question
Find out whether there is any statistical evidence to suggest that tests of gas consumers are related to country of origin. So where is your computation?
This is my computation part one.
Yeah.
And I've got this.
Compute the coefficient of determination.
This
The
is
R squared. Yeah.
So after computing the coefficient of determination?
Yeah, you can conclude.
And how do you conclude?
What is the square? Yeah, so each of them determines the other up to a given extent. So there's a statistical evidence.
0.39.
So 39.7% of each represents the other. If one was the dependent variable and the other is the independent, it means it would represent the other up to this extent. You get me?
So this is They just needed you to compute the coefficient of determination, and then basing on the levels, you get the percentage.
You get the percentage. The coefficient of determination can be a percentage or just a proportion, like it is here. Yeah, 0.397 of the independent variable of the dependent variable is determined by the independent. But when you put it in percentage, it is it is more, you know, explanatory.
The number if you want to do.
You're welcome, sir.
I'm going to enter when I'm not well confident with calculus, but I will try my level best.
Calculus?
But I will try my level best.
Yeah, do your best. Get them recording or you will say.
I will try on probabilities.
But you said you're going to take us through.
Yeah, and it is simple. You see this? You see this? You see this? This is 3 standard deviations. You can see. You see 3 and standard deviation. It's written as x bar plus or minus 3 standard deviations over square root n. So these are the limits. The lower limit is when this is a minus. Okay? Mu 1 x bar minus 3c. Control charts are no, control charts are confidence intervals, if you remember. So this is the first mu. The second mu is when it's a plus.
Yes, sir, I failed to do the graphs. But
Which graphs for control charts?
Getting the center line.
No, that's simple. We shall do. So this one here, this is the lower control limit. This is the upper control limit. The center line is x bar. Okay, so when it comes here, find the upper and lower control limits. Says no one. You just fill in this. This is 2 marks, 2 marks. That's why it's 4. So he guides you on which formula to use. The same thing with proportionate control charts. So he would do the same.
Then you used about the other two. If you're not given, you see the given this.
Where there is a missing figure.
No,
Go ahead. Go ahead.
They've given that one, but they've not. The examiner has not told you which one is the best. Okay.
Whenever it doesn't specify the base period, you go with the prior period. So in this case, 1998 was the best period. Yeah. You always go with the prior period. Yeah.
No, this one has
Then this is the price.
No, here you make it even easier. Yeah, he's telling you, you take this as your weight because it's as far as quantity. Oh, sorry, price is the weight. You know what? Yeah. The best period price is here. The quantities are here. Best, and then.
I had noted something to ask you. I don't know if that disappeared.
Have you understood me? No, can you write the formula? That's when you'll understand what I'm talking about. You write the formula for Laspers quantity index. Okay?
Yeah.
Write it. That's when you'll understand what you're talking about.
What about this one here? The mean sales.
Yeah.
Like past 200 days, the sales of bread from the bakery have been followed. Sales and the number of days.
Yeah.
So the mean sales of bread.
Yeah.
Summation.
FX. It is ungrouped data with frequencies. So summation FX. So this is X, this is F, you need FX. So X bar is summation FX over summation F. Yeah. So he used the expectation. This could have been probabilities, maybe 10% and so on.
Yeah, it is this one, sir.
Where you use X bar is summation X times probability of X. So I'll need X, probability of X, X times probability of X. The total of this is my expectation.
And this is the mean.
That will be the mean. Yeah.
Thank you.
You don't divide. You don't divide by number of items. under expectation. Yeah.
Excuse me, sir.
This is Las Paz what? Quantity or price? Okay, this is price. They wanted quantity index. You know what I mean? Yeah, so the quantity index, summation Q1 times P naught, summation Q naught times P naught. So in the table, if you saw, he has given you P naught for 1998. You have it. The quantity 1 and quantity Q naught you have. You know what I mean? Yeah. Okay, guys, have a good night. Until then, you're welcome.
Excuse me.
Yes, please.
Can you help us with game theory tomorrow?
I sent you notes. Did you use them?
Yes, but I didn't understand him very well.
Yeah.
Most of PDFs are invalid formats, so they don't open.
Invalid formats. Okay, let's meet tomorrow. Hope I can do something with you. Yeah.
Okay.
But I need you to have like red. That's the thing. Because there's where the game must end or continue. There are a couple of definitions we need to do. Okay, I'm going to take screenshots and share so that you read through and we have a discussion.
Okay.
Yeah, I know.
But there's way to explain and summarize everything.
Okay. Guys, have a good night. Bye for now.
Good night.
You too, please.